Another question, you got it. Sinusoidal functions, but I'm not going to give you the equation again. And you're going to get more and more practice with this, and you're going to find out figuring out the equation is actually kind of easy. So here we go. We got a nail. It's caught in a tire. Look at that. Check it out. So there's my nail right here. And as my tire rotates, the nail rotates to the top of the tire. And then eventually it hits the bottom, which is the asphalt. And you're going to hear this. You're going to hear a tick sound. Okay? So when you're driving along and you've got your window open and you hear this tick, 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 that's chances are you got a nail stuck in your tire and you better get that fixed. You're going to get a flat soon, and you're going to be in all kinds of problems if you do. Okay? So here's the cool thing. It hits the bottom. Okay. Then it rotates back to the top and it hits the bottom. Sinusoidal function. There it is. Okay? Now, the cool thing about this, though, is this. Check this out. If I knew the diameter of the tire, I can figure out a whole bunch of... Wait a second. What's that? The diameter of the tire. Dun, dun, dun. So check this out. Isn't the diameter of the tire 50 centimeters? Which means it's going to go to a maximum height of 50. It's touching the pavement, so it's going to be at 0. So check this out. Can't I find the amplitude and the D value right off the bat? Sure can. Amplitude, remember, is the maximum minus the minimum over 2. Oh my goodness, it's 25. Well, yeah, no kidding. If you got a diameter here of 50 centimeters, think about it. 25, which is right here, your amplitude, of course, is going to be 25. It's going to go up 25 and down 25. Makes sense. How about the D value, right? Well, this is 50 plus 0 over 2. 25 again. Think about it. Isn't the center going to be 25? Makes sense, right? Yeah, Okay, so now I got the A, I've got the D. Wouldn't it be great to figure out the period? Well, here's the problem. I'm telling you that this revolves 10 revolutions per minute. When you're thinking about period, think about period as how much time for one revolution. Think about that. That's what period actually means. How much time for one revolution? Well, think about it. The time here is, this is per minute. So it's 60 seconds, right? For 10 revolutions, which if you think about it, cancel it out, takes you 6 seconds for one revolution. And guess what? There's your period. Oh, from there, that's easy now. I can figure out my B value. My B value then is 2 pi over the period, which is 6. So you can write this down as pi over 3. Oh, yippee skippy. Look at that. I've got everything I need here. Well, yeah. What kind of function are we after here? Take a look. Doesn't that look like a sine function to you? Yep, I think so too. So it says determine a positive, it doesn't want a sine function. It wants a cosine function. Dagnabbit. Man. Okay, well, think about this. Doesn't this take 6 seconds for one complete revolution? So I got a question to ask you. That right there would be 3 seconds, wouldn't it? Halfway through. Wouldn't that be for one complete? So my question then is, how long does it take you to get to the top? Half of 3 seconds, right smack in the middle. So it's 1.5 seconds for it to revolve that nail to the top. Guess what? There's where your cosine function is going to start, because cosine function is from a cup, top to top, right? Okay, so now we got everything. We even got the shift, and the shift being 1.5 seconds to the right. I'm loving this right now. Okay, so here we go. Let's do our determine the positive cosine function for the motion of the nail. Okay, so how are we going to do this? Of course, we're going to do this as height as a function of time, right? Our A value, which I figured out, which is right here, this is going to work out to be, of course, our A value, which is 25, right? This is going to be cos, positive. Our period right here, pi over 3. How nice. Okay. Our shift is going to be time shifted to the right, because I'm going to start here, not at 0, at 1.5 seconds, 1.5. And my d value, of course, is going to be 25. There we go. There's my beautiful equation. Isn't that pretty? Sure it is. Now look at this question. It says, can you determine a sine equation for the motion of the nail? Oh, well, come on, make up your mind. Well, actually, the sine equation's a lot easier. Because look, the sine starts at 0, goes up, goes down. There's our sine equation. If it starts at 0, makes it so much easier, there's no shift. 25, the same d value, the same amplitude, same everything. Everything's the same, but now you're going to go sine. There's your pi over 3. Notice that there's no shift because you're starting right here at 0, so that's just time. And of course, your d value, which was plus 25. Boy, that makes it nice and simple now, doesn't it? Okay, now it says estimate here. How far is the nail above the ground to the nearest tenth at 6.5 seconds? Oh, all you got to do then is just put in 6.5 seconds. It's a value. Chuck it in there. I'm not even going to use my calculator. I want to find the height at 6.5 seconds. I'm not going to draw this out. What's the point? Look, there's the pi over 3. There's the 6.5 seconds. I'm going to put it in with the 25. I'm going to throw this directly into my calculator. Look how pretty this is going to be in your calculator. Here we go. 25 sine. Don't forget that's pi over 3. So I'm going to put in my fraction. Pi over 3. Perfect. Put my bracket in here. There's my x. But my x, if you think about it, remember, this was at 6.5 seconds. Okay, 6.5 bracket. I'll need my other bracket to close it off, right? Plus the other 25, my d value. Punch it. What do you got? Well, this is going to be at 37.5 centimeters high. Yep, there you go. That's it. So 35.7 centimeters. Let's put it in there. 35.7 centimeters. And it says to the nearest tenth. So, yep, perfect. Great. Now, estimate now again to the nearest hundredth of a second. Oh, this is getting interesting. Okay, one time when the nail is 30 centimeters above the ground. Now it's 30 centimeters above the ground. So think about what we have here. Think about the equation. The equation was h of t equals to 25 sine pi over 3 of x, right, plus the 25. Now I'm telling you the height is 30. Let's just do this algebraically. Let's do it. Okay? So in other words, I want to find this x. I can do that, no problem. Let's go. The height is 30. Okay, there's 30 equals to 25 sine pi over 3. That's the x what I'm trying to find. Or they like it better as t. So maybe I should have wrote this as t over here. Whatever. It's still a variable. Plus 25. Okay, start solving this. Subtract 25 from both sides. Oh, that's easy enough to do because then that cancels. That, of course, gives you 5 equals to 2 sine pi over 3 t. Okay, now, how do I solve the rest of this? Well, divide this by, of course, my 25. Oh, that's supposed to be 25. Divide this by 25. Divide this by 25. Okay, so I got 5 over 25 equals to the sine of pi over 3 times t. Now, algebraically, there's some really cool stuff that happens here that you got to figure out. But you know what? At this point in the course, I'm not going to go out and start teaching all kinds of weird-looking algebra. At this particular point in the course, I'm just going to say, put this in as y1, put this in as y2, and solve your problem. Okay? So let's do that. Let's put this into the calculator, y1, y2. You know that this 5 over 25 is 1 over 5, so there's your y1. Chuck that in there. Okay, so here we go. y1. Okay, I always like using the fractions. So, yep, 1 over 5. Perfect. Okay, right? y2 then would be your sine function. Your sine function, of course, being sine pi over 3x. Okay, sine pi over 3, right? X. Perfect. graph it. I don't know what this graph is going to look like. Oh, it looks horrible. So if it looks horrible, you can really just go hit zoom and hit trig 7. And that should do it real nice for you, doesn't it? Look at that. Beautifully. Okay, so it says to the nearest second, one time when the nail is 30 centimeters. There it is, right at 30 centimeters, right there, right at that intersect. So let's find out that intersect. Second calc, find me that intersect right at that time. Enter, 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 and look at this. This is actually at 0.19 of a second. So write down your answer, 0.19 of a second. You got it. That's how you do it. So sometimes it's beneficial to do the graphing for it. Once you simplify the equation down, it makes it a lot easier to graph.